Hello everyone, I am Mary Swarnalatha, working as an assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the joint moments about the origin and the joint moments about the mean. So already we have finished the moments about the origin and moments about the mean for a single random variable. For example, if x is a random variable, then the nth moment about the origin has been expressed by expectation of x power n. This is the moment about the origin. And similarly, the moment about the mean has been represented by the symbol mu. So mu n is equals to the nth moment about the mean has been represented by mu n is equals to what? Expectation of x minus x bar power n. Here what is x bar? That is nothing but what? Expectation of x only. So this only have discussed. Now the same concept we are applying for two random variables x and y. So for example, if x and y are two random variables, then the joint moment about the origin of the order m plus n. If it is a single random variable, the order is what? N. For two random variables, what is the order here? M plus n. So which is given by what? M suffix n comma k is equals to expectation of x power m into y power n. Here what is expectation? Expectation nothing but what? The statistical average. The statistical average of power of the random variable x to the m and power of the random variable y to the n is given by m suffix n comma k, which is called as what? The joint moment about the origin of the order m plus n. Now we have seen the types of random variables are continuous random variables and discrete random variables. So for x and y are two discrete random variables, then joint moment about the origin of the order m plus n is defined as what? M suffix n comma k is equals to what? Expectation of x power m into y power n. That equals to what? Sigma. So already we know that what is expectation of g of x comma y. We have seen the expectation of the operation of multiple random variables. For discrete random variables, what is the formula? Sigma xi yj. Sorry, it is nothing but this is g of xi comma yj. So what are the function is there? That function you have to write down into the joint density function at the variables xi comma yj. This is nothing but ing. So the same thing here. What are the x and y here? They are discrete random variables. Then what is the expectation of x power m into y power n is equals to what? Sigma x, sigma y, x power m into y power n, fxy of x comma y. Here dx dy will not be there because there is a summation. Only for integration you will get the dx and dy. For summation what do you get here? Fxy of x comma y. Or else I can write down this function as what? Sigma. So sigma I, sigma j, xi power n into yj power n into fxy of xi comma yj. In place of x and y, what is here? Xi and yj. Then what is fxy of xi comma yj? Is nothing but what? It is a joint probability such that p of x equals to xi and y equals to yj. So like that we can calculate the n plus kth order joint moments about the origin for discrete random variable. For discrete random variable, you have to take what? The summation. Since you have two random variables, you are getting the double summation here. So expectation of any function is what? That function into density function. So for discrete random variable, the density function is nothing but what? The probability mass function, and nothing but the joint probability mass function only. Now, if x and y are of continuous random variables, then what is the joint moment about the origin? M and k is equals to what? Expectation of x power m into y power n. In case of continuous random variables, what is expectation of any function? How many random variables here have? Two random variables. That's why here I'm getting the double integration where x is from minus 1 to infinity. The random variable is y is defined from minus 1 to infinity. So expectation of any function is what? That function. So x power m into y power n into the joint density function fxy of x comma y into dx into dy. So like that, this is a formula to calculate the n plus nth order. M plus, this is m and this is what? N. So m plus n order continuous random variables joint moment about the origin. Now, so what is the nth order? N plus k order. If I take m comma n is n plus n order. If I take only n comma k, so it is nothing but what is order here? N plus k. Therefore, for m, what is the formula? Expectation of x power m into y power k. So, what is the order here? The order is equals to what? N plus k. What is the order of these joint moments about the origin? Why it is about the origin? Because expectation of x power m is nothing but x minus 0 power m into y minus 0 power k. Since it is about the origin, the variation, it is called as what? Joint. Why it is called joint? Since we have more than one random variable, we are calling it as what? Joint. So, joint moments about the what? Origin. And what is order here? N plus k. Now, let us see the first order. Let us see the first order joint moments about the origin. Now, order n is nothing but what? Here, order is nothing but n plus k. What is that value is equals to 1. So, when can you obtain n plus k equals to 1? If n equals to 1 and k equals to 0, one case. And what is the second case here? This is the first case. And what is the second case? N value is 0 and k equals to 1. So, for first order moments, how many combinations of for n and k you are going to get? N is 1, k equals 0. This is a one combination. The other combination is what? N equals to 0 and k equals to 1. Then, the first order moments about the origin. So, what is the first? So, here what is the first set? N is 1, k equals to 0. So, is equals to what? Expectation of x power 1 into y power 0. That equals to what? Expectation of x. So, what is the expectation of x? Nothing but what? The mean of x. Nothing but x bar only. Therefore, this is called as what? Mean of the random variable x. Now, what is m01? Nothing but expectation of x for nothing but n is 0 and k equals to 1. So, that equals to what? Expectation of y. So, what is the expectation of y? That is nothing but what? Mu y. Nothing but the mean of the random variable y. Therefore, what are the first order moments? M01 is nothing but y bar and M10 nothing but what? The mean of the random variable. Therefore, the first order joint moments about the origin gives the means of the two random variables respectively. Now, we'll go for second order joint moments about the origin. So, what is the joint moments about the origin formula? Expectation of x power n into y power k. Now, second order, nothing but what is order for m suffix n comma k? Nothing but n plus k. So, what is the order here I am giving here? Second order means what is my n plus k equals to 2. So, how many cases are going to get n plus k equals to 2? The first case is what? N equals to 2 and k equals to 0. Second case is what? N equals to 0 and k equals to 2. Third case is what? N equals to 1, k equals to 1. Therefore, how many combinations are going to get for the order 2? Totally, there are 3 combinations. The first one is n value 2, k equals 0. And the second one is n is 0, k equals to 2. And third one is n is 1 and k equals to 1. Now, we'll go for the first combination. What is the first combination here? M20. Nothing but what? Expectation of x square into y power 0. What is y power 0 equals to 1? Therefore, this is nothing but what? The mean square of the random variable x. Now, n equals to 0 and k equals to 2. So, what is my n value? 0. And what is my k value here? 2. So expectation of x power 0 into y power 2. Nothing but what? Expectation of y square. Therefore, what is m0 is equals to expectation of y square. This is called as what? Mean square of the random variable y. And what is the third combination here? N is 1 and k equals to 1. Nothing but m1, 1. So n is 1 and k equals to 1. Then what can happen here? Expectation of x power 1 into y power 1. So it's nothing but what? Expectation of xy. So this is called as what? Correlation between the random variables x and y. Therefore, m11 is nothing but what? It is a correlation between two random variables x and y. So like that, similarly can calculate the joint moments about the mean. Previously I calculated about the origin. About the origin nothing but x minus 0 power m into y minus 0 power k. So this is n and k. So here also you'll get here n and here what? K. Okay, therefore for two random variables x and y, what is the joint moment about the mean? About the origin is represented by the symbol m. About the mean, this is also called as what? The joint moments about the mean is also called as what? Central moments also, which has been represented by the symbol mu. So mu suffix n comma k. What is the order here? The order here is nothing but what? N plus k is equals to what? Expectation of x minus e of x power n into y minus e of y power k. That equals to what? Expectation of x minus x bar power n into y minus y bar power k. So this is called as what? The joint moments about the mean of the order n plus k. Or else the other name for joint moments about the mean nothing but the joint central moments. Now for example, if this x and y are discrete random variable, then what is the joint moment about the origin? What is the formula? So expectation. So for discrete random variables, how many random variables you have? Two random variables. So for discrete, we have to take the summation. Therefore, xi minus x bar power n into yj minus y bar power k into fxy of xi comma yj, where sigma I and j. So what is fxy of x comma xi comma yj is nothing but what? The joint probability such that p of x equals to xi and y equals to yj. Therefore, for two discrete random variables x and y, what is the joint moments about the mean is given by what? So sigma. So expectation for discrete random variables, we will calculate sigma. For the continuous random variables, we will take integration. For discrete random variables, we will take the summation. Okay, therefore, since we have two random variables x and y, I am taking the double summation. So sigma I, sigma j, xi minus x bar power n into yj minus y bar power k into fxy of xi comma yj. This is the probability mass function. Nothing but for discrete random variable, this is called as what? P of x equals to xi and y equals to yj only. Now, if x and y are two continuous random variables, then what is the joint moments about the mean is given by what? M suffix n comma k. So here I am taking the order of n plus k. Then what can get here? What is the formula for the joint moments about the mean? Expectation of x minus x bar power n into y minus y bar power k. So expectation, how many random variables do you have? Two random variables. What are those two random variables here? They are continuous random variables. So for continuous random variables, to calculate the expectation, we have to take the integration. Since two random variables, I am taking the double integration, where the value of x is from minus infinity and the value of y is from minus infinity. So expectation of any function is what? That function you have to write down here. What is the function here? X minus x bar power n into y minus y bar power k into the joint density function of these two random variables. What is the joint density function of these two random variables? Nothing but what? fxy of x comma y into dx into dy. Therefore, this is what the n plus kth order joint moments about the mean for two continuous random variables. Now, what is the order here? The order of these joint moments nothing but what? N plus k. Now, what is the formula to calculate the joint moments about the mean of the order n plus k? Nothing but what? For two random variables x and y, it's expectation of x minus x bar power n into y minus y bar power k. Now, we'll calculate the first order joint moments about the mean. The joint moments of the mean are also called as what? Joint central moments. So, now what is order should be is equals to 0. So, it is nothing but n. First order means n plus k is equals to 1. So, how many combinations are going to get? Two combinations. One is what? N is 1 and k equals to 0. The other combination is what? N value is 0 and k value is 1. Now, what is the first order here? Mu 1 0 is equals to what? Expectation of x minus x bar power 1 into y minus y bar power 0. That equals to what? Expectation of x minus x bar. That equals to what? E of x minus E of x bar. What is E of x? Nothing but x bar, the mean of x. And the mean of x bar here constant. The expectation of any constant is the constant is equals to 0. Therefore, what is mu 1 0 equals to 0. And similarly, what is mu 0 1 is equals to expectation of x minus x bar power 0 into y minus y bar power 1. That equals to what? Expectation of y minus y bar. What is that value is equals to 0. Therefore, what is mu 0 1 is also 0. Therefore, what are the first order joint moments over the mean are equal to mu 1 0 and mu 0 1 is equals to 0. Now, let us calculate the second order joint moments about the origin. So, the second order means n plus k equals to 2. So, n plus k equals to 2 means we are going to get totally 3 combinations. What is the first combination? N need 2 and k value 0. Next one is n 0 and k equals to 2. And next one is what? N value is 1 and k value is what? 1. Now, so for n equals to 2 and k equals 0, it is called as what? Mu 2 0. Nothing but what? Mu 0 2. It's nothing but what? Mu 1 1. Now, what is mu 2 0 equals to? Expectation of x minus x bar power square into y minus y bar power 0. So, here n is 2 and k equals to 0. That's why here. That equals to what? Expectation of x minus x bar whole square. What do you call this? Nothing but what? The variance of the random variable x. And similarly, what is mu 0 2? That is nothing but what? Expectation of x minus x bar power 0 into y minus y bar power 2. That equals to what? Expectation of y minus y bar whole square. What do you call this as? This is nothing but what? The second order moments about the nothing but sigma y square is called as what? Variance of the random variable y. And what is the second order mu 2 0 equals to? Sigma x square nothing but what? Variance of the random variable x. Now, we'll see what is mu 1 1. What is mu 1 1? Nothing but expectation of x minus x bar power 1 into y minus y bar power 1. That equals to what? Expectation of x minus x bar into y minus y bar, which is called as actually the covariance of two random variables x and y. Therefore, what is mu 1 1 is nothing but what? The covariance between two random variables x and y. Now, if you simplify this, what can happen here? Here, this is x into y. Nothing but xy minus x into y bar minus x bar into y plus x bar into y bar. That equals to what? Expectation of xy minus expectation of x into y bar minus expectation of x bar into y plus expectation of x bar into y bar. That equals to what? Expectation of xy minus, here y bar nothing but mean of y which is constant, bring it outside. Then y bar into u of x minus, here x bar is constant, bring it outside. X bar into u of y plus x bar, y bar both are constant. The expectation of any constant is the constant itself. Therefore, u of xy minus y bar. What is u of x? Nothing but the mean of x. Minus x bar into u of y, nothing but the mean of y. Plus x bar into y bar. So therefore, what can you obtain here? U of x minus x bar into y bar, which is called as what? Covariance. What is u of xy? Nothing but the correlation Rxy. Previously have seen M11. So minus x bar into y bar, which is called as what? Covariance between two random variables x and y. Now let us see a problem. Let x and y have the following joint probability density function. Find the moments about the origin. Find the joint moments about the origin. Fxy of x comma y. What they have given that? They have given that the joint probability density function fxy of x comma y is equals to 3 into x plus y when x is what? 0 to 1 and y is from 0 to 1 and it is 0 otherwise. What you have to calculate? You have to calculate what? Joint moments about the origin. It's nothing but what? M suffix n comma k. What is that? Nothing but expectation of x power m into. So this is x m and k is equals to what? Expectation of x power n. This is n here. Therefore here the order is k. Therefore here k. So expectation of x power n into y power k. So these two random variables are which type? They are of continuous random variables. So for continuous random variables, then what is the joint moments about the origin? Nothing but integration minus infinity x power n into y power k into. So what is here? X power n into y power k. Expectation of any function is what? That function into the joint density function. So fxy of x comma y dx into dy. Now what is my x value? They have given when x is 0 to 1 and y is 0 to 1, the joint density function is equals to 3 into x plus y. Therefore the limits my now 0 to 1. So when x is 0 to 1 and y is 0 to 1, what is the joint density function? They have given that 3 into x plus y into what do you have here? Dx into dy. That equals to integration 0 to 1. Okay, integration 0 to 1. Here 3 is constant. Bring it outside. So x power n into x. Nothing but what? X power n plus 1. Next y power k into y. So what can you obtain here? X power n into. So here x power n plus 1 into. So I done first here. So x power n y power k into x. So plus what do you have here? X power n into y power k into y into what here? Dx into dy. That equals to what? 3 into integration 0 to 1, 0 to 1. So x power n y power k into x. Nothing but what? X power n plus 1 into y power k plus x power n into y power k into y. Nothing but what? Y power k plus 1 into what do you have here? Dx into dy. So that equals to what? 3 into integration 0 to 1. So what is the first function? X power n plus 1 into y power k dx dy plus integration 0 to 1, 0 to 1. What is the second term here? X power n into y power k plus 1. So here x power n into y power k plus 1 dx into dy. that equals to what? First integrate with respect to y. Then what can you obtain here? Integration 0 to 1 x power n plus 1 into integration of y power k is y power k plus 1 by k. And the limits are from 0 to 1 into what you have here dx plus 0 to 1. So it is 0 to 1. So x power n into what is integration of y power k plus 1? Nothing but y power k plus 2y k plus 2 and the limits are from 0 to 1 into what you have here dx. So that equals to 3 into integration 0 to 1 x power n plus 1 into substitute the limit. Then in place of y you have to substitute the limit. So 1 power k plus 1. What is 1 power k plus 1 is what? 1. So 1 by k, and if y equals 0, 0 power k plus 1 is 0. Therefore what can happen here? 1 by k into what you have here dx plus 0 to 1 x power n into, if you substitute the upper limit here in place of y. So 1 power k plus 2. So what is 1 power k plus 2 is what? 1. So 1 by k plus 2. Minus lower limit is what? 0. So 0 power k plus 2 is nothing but 0 by k plus 2 is 0. Therefore here, what can you obtain here? 1 by k plus 2 dx. That equals to 1 by k is constant. So bring it outside. 3 into 1 by k into integration of x power n plus 1 is x power n plus 2 by n plus 2 and the limits are from 0 to 1. And similar here also 1 by k plus 2 is constant and integration of x power n is what? X power n plus 1 by n plus 1 and the limits are from 0 to 1. That equals to what? 3 into 1 by k into. So substitute in place of x because integration with respect to x. What is the upper limit here? 1. So 1 power n plus 2 is what? 1. So what do you have here? 1 by n plus 2. And the lower limit is 0 because 0 power n plus 2 is 0. That's why the lower limit is here 0. And then 1 by k plus 2 into. So what can you obtain here? To substitute the upper limit, 1 power n plus 1 value is what? 1. So 1 by n plus 1. And what is the lower limit? 0 power n plus 1 is 0. 0 by something you are going to get 0. That's why here you are going to get like this. Then what is here? So then you are getting here 1 by k into n plus 2 plus 1 by n plus 1 into k plus 2 into what here? Totally you are having into 3. So here integration of y power k is y power k plus 1 by k plus 1 here. This is not k here, this is k plus 1. So here also it is k plus 1. So here what can you obtain? K plus 1. So this is what the n plus k or order joint moments about the origin. So like that you can calculate. Now for example, if they are asked to calculate the mean from this, how can you calculate the mean if you know the joint moment about the origin? So what is the mean is equals to, you have calculate what is the mean of x? Nothing but m10. And what is the mean of y? m01. Now you know m and k. Then what is m and k got here? M suffix n comma k equals to 3 into 1 by k plus 1 into n plus 2 plus 1 by n plus 1 into k plus 2. Now they ask to calculate the mean. How? Mean of x and mean of y. How do you calculate? In that substitute n value 1 and k value 0. Then what can happen here? N value is 1 and k equals to 0. So k equals to 0 here. N value is what here? 1. Then what can you obtain here? So here you will obtain 1 by k 0. So 0 plus 1 is nothing but 1. And here n equals to 1. So 1 plus 2 is nothing but what here? 3. Plus 1 by here n value is 1 and k equals to 0. N value is what? 1. So 1 plus 1 is nothing but what? 2 here. Into what is the k value here? 0. So 0 plus 2 equals to what here? 2. So if you take the LCM, Then what can happen here? 3 into 4, nothing but here 12. So here this is nothing but 12. Next you are going to get 3 into, so 4 plus 3. Nothing but what? 3 ones are 3 fours are. So 7 by 4. Therefore, what is the mean of x? Nothing but what? 7 by 4. Similarly, you can calculate mean of y by substituting n value 0 and k value is 1. Like that, you can calculate the means, variances and like that. Hence, by substituting in the formula of m suffix n comma k, which is called as what? Joint moments about the origin. So, therefore, in today's lecture, we have discussed about the joint moments about the origin and the joint moments about the mean, which are also called as the joint central moments, and a problem on this joint moments about the origin. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.